Okay, so I want to, every time I try to make a video, it ends up being like 40 minutes long. So I'm going to try to cut my project into small, digestible chunks, maybe 10 minutes, and put out a bunch of videos about different slices. Um, so um, let's kind of give a quick overview of the project. Um, so if I want to run my monitoring. I can just run my Grafana container, which contains it has a data source for BigQuery. So all of um, my metrics from my inference from training are output to BigQuery, and it's mostly kind of like a monitoring dashboard for reviewing um, how the new versions of my model are performing compared to previous versions. And so let's change model A to the original base model, and model B to the fine-tuned model fine-tuned from that base model. Basically, what I'm doing here is following something called a champion challenger pipeline approach. So I take a base model, in this case, it's a MobileNet um, computer vision model, and it's pre-trained on the ImageNet dataset, which contains thousands of classes. Um, and my target dataset is just dog images with labels for each breed. And so since the ImageNet pre-training set has um, dozens of breeds in it already, right out of the box, it's able to do pretty well. As you see, around 55% accuracy out of the box. And so my training pipeline um, uses this base model as the original champion model. And everything that's fine-tuned from that base model will be a challenger model. And for each run of the pipeline, the training, the data set processing, the deployment of the model to my inference application, all of that is done in a Kubeflow pipeline. It's all completely automated, and it's triggered by a cloud function which inputs certain parameters into the pipeline, and that cloud function is invoked via a cloud scheduler that runs on whatever type of cron expression I want to run it on. Usually, I've been doing it once a day, and then I've had my inference service do a prediction kind of every minute, so that gives me, a good collection of data for each day to compare between models. And so in that cloud function, when it receives a request or a trigger payload from the cloud scheduler, it will review a state file. I've created a state file that keeps track of my current champion and current challenger version. It will grab those versions, query BigQuery, and check and see which um, which version of the model has had better performance. So if we look at that cloud function code, we see this evaluate models function, which checks the current versions, um, and then it outputs results and then returns which version of the model has better accuracy. So over here on the right, you can see that the original base model would be the champion. That model, the champion service, these are two different Cloud Run services. The champion service would stay the same, and then the challenger service would then get redeployed with a new version of the model that's trained with new data. And so when that happens, we see a change in our monitoring. We see, okay, so version 3.2 is up to 40% accuracy. still not beating the champion version. So it'll need to be some more fine tuning that takes place um, before it can reach the level of the base model. And so without spending too much time digging into the details of the architecture of the model, there were some changes that have to be made to the actual MobileNet model. So the MobileNet model um, that's pre-trained, and then it has a specific what's called a classification head, which uses some function called a softmax function to determine based on the features um, identified um, in the inference uh, on the image to determine a prediction. So it outputs a value for each label in the training set or in the classification head, um, and then whichever has the highest confidence is the number one prediction generated by the model. And so if you can imagine like this long list of values in the case of um, ImageNet, it'd be like over 1,000 different things, entities, like a person, a car, a dog, a Labrador, a poodle, a tree, etc. And then it would return the probabilities um, of each thing being the prediction, uh, being what the model predicts, right? And so in the case of ImageNet, you're going to have this big classification head of all sorts of different things. We removed that classification head. I've removed the classification head, and then used the number of dog breeds to create a new set of mappings for my softmax, which correspond to it's 160 breeds basically in this open database that I'm using. And so what it will do now is it'll take up, the predictions, the feature maps, and the determine of this 160 um, classes, which one is most likely, which rank each of these and the probability that the input image is that class, um, and then it'll return them in order of confidence. Um, so one thing to think about is like the labels um, that the original base model was trained on have different spellings, a different format. Maybe they have underscores, capitalization, etc. Maybe they've abbreviated words or just spelled, like let's take for example hound blood, hound basset. My naming convention from my target data set is hound blood, hound basset, setter English. Maybe ImageNet they named bloodhound, right? So they reversed the order of the words. And so there's some changes that I'm still kind of trying to understand with the base model's predictive ability when you change the classification head. Um, because now we're working with different labels. So, after one training run, we're able to get an accuracy um, that's that's still a little less than the base model. After the first training run, the accuracy is much less than the base model. And what could be happening here is the model's um, classification head being different maybe makes it harder for it to make a prediction on a specific set of features for any given dog breed. And so it's possible that um, we'll need to unfreeze more layers as we continue to fine tune. Currently, I'm unfreezing about, we look at the model.py, I'm unfreezing about 20 layers. So where is that? Yeah, so I'm unfreezing 20 layers, and everything else in the base model is frozen, meaning it's not trainable. Those weights will not change. The idea with that, and you want to unfreeze the 20 layers before the output layer, which is the classification head. Um, and so once you've changed the classification head to your new target data set, you retain that classification head for each subsequent model version that's fine-tuned. But those 20 layers at the end of the network before your classification head get the weights for those layers get updated each training run based on the new training data. And so the idea is we retain all of the basic features from the original training set, which include like just, understanding vertical edges versus horizontal edges. Um, and so it starts, the neural network, this convolution neural network starts with picking up really basic features, vertical edges, horizontal edges, like rough edges, smooth edges. And so all of that training, we want to retain it because it should be the same for our target data set. But the last few layers, so if these models have dozens of layers, and the features that they recognize or output and feed into the next layer are more and more complicated as they go along until finally towards the end of the model's layers, it has semantic features. So it knows that this type of ear or this type of coat or face shape is associated with um, a Shih Tzu or a Bloodhound or a Doberman, etc. And it's those last rich, complex layers that we want to fine tune um, toward our target data set. So I hope that makes sense. So what we're seeing quickly is the first version does well. We remove the classification head, unfreeze the last 20 layers, and then fine tune those layers. And then we get a huge drop off in performance. We do another fine tuning run. We get an increase in performance. We do another fine tuning run and we get another drop in performance, which is interesting. So we're worse than 3.1. So we went from 3.1, 35, 3.2, 40 to 3.3, which is now dropping back down to 30% accuracy. So this is where the fun stuff comes in, right? We have to evaluate what's happening in our pipeline. Everything's automated. We're using Kubeflow, using Cloud Run, GCS, Vertex AI for training, and running data flow jobs to process our images. Now we have this rich system that we've built, and now it's time to figure out like what's happening, right? So this is where you have to be very thorough with tracking everything. And Vertex AI, we'll do this in another video. We'll go into how Vertex AI experiments work. With in this case, I'm using TensorBoard to track my training metrics, so we can look at different training runs in my data set creation pipeline. When I process images from a raw JPEG into a TF record format, I've added some code that will output the distribution of each training set to GCS so that I haven't added a visualization panel for that, but it will look probably something like this, where I can look at for each model version, what was its training set distribution like? And there I can see, okay, is this model getting worse on a particular set of breeds? So it starts off in this panel here. What I'm trying to visualize is a set of classes for each model version. So I've taken this set of classes, Bloodhound, Basset Hound, Shih Tzu, English Setter, because they were particularly good. My original model was particularly good at recognizing those. And then I want to visualize how the predictions for those labels change over time. And as you can see, the huge drop off here from the base model to the first fine-tuned version. And then we see a little bit of an increase, right, for these models. So like say the Basset Hound actually got a lot better prediction accuracy, going from 0 out of 4 to 8 out of 12. That's a huge jump. But then weirdly enough, we see it drop back down to 2 out of 14. So just intuitively, I'm thinking that's some sort of catastrophic forgetting, right? So those layers, those 20 layers, I'm fine tuning them on one particular distribution from my training set, my process training set. And then I fine tune them again on a slightly different distribution of dog images because I'm just randomly pulling a collection of around 2,000 images from the images that my model has run predictions on. And so one thing I'm going to do is, output correct predictions to a certain bucket, incorrect predictions to another bucket, and then probably focus on training on those incorrect predictions. But then again, as even within those incorrect predictions, there's going to be different distributions of dog breeds. So I need to understand how those different distributions affect the learning of my model and design a different sort of training architecture to prevent this issue that we're seeing here, which is probably some sort of catastrophic forgetting, if you've heard of that. Okay, and then so that's it for this video. I want to keep it short, but next we can go into more specifics about how Kubeflow orchestration works, maybe investigate some of the stuff I've mentioned with data set distribution and how that affects each training run. And then I'm going to try it all again. I'm going to reset everything, start it back from the base model, let it run for several days and see kind of what the results are.